Hello, ladies and gentlemen. My name is Decryption, and I hope you are well. The Gameplay Ability System, or GAS, is a framework or feature of Unreal Engine that lets you easily add abilities and a good framework to build your game upon. But it's always been looked down on because it takes some C++ to implement. I will say, I can code in C++, but I also used to look down at it and avoid it because it took the C++. And every time I try to look into it, it's this big complicated thing. But recently I've been using it more and more in my game jam demos or client work because I figured something key out about it. If you remove all of the replication and multiplayer, it's like 20 to 30 lines of copied and pasted code. That's it. It's so much easier to add. So, we're going to do that today. We're going to add the gameplay ability system, GAS, from Unreal into a single player project. So let's get started. So if you don't know, what is the gameplay ability system? Because you'll see it everywhere. Everybody talks about it. You might not have ever used it. So it is a basic core concept of 4 things typically: an ability, a queue, an attribute, and an effect. An ability is literally what it says. It gives you the ability to do something, a task or a job you can do. Jumping, walking, sprinting, crouching, attacking, shooting with a specific gun, the ability to pick things up. Any logic you can think that you can say, start this, can be added to an ability. That is what an ability is. The ability system allows you to grant abilities to people. So these guys will have the ability to walk around. This guy might have an ability to be a shopkeeper. This guy will have the ability to attack with swords, whereas this guy has the ability to block and jump really high. And that's the benefit of it. You create one ability, and then you can put it on anybody who has an ability system component, and they will be able to use it. The other ones are gameplay cues. That's how you activate special effects on a trigger. So you might say, when damage is hit, spawn blood using a gameplay cue, or spawn some sound. You don't have to use them, it's just built in and it's the nicer way to do it. So you could say if anybody in this world is a type of elf, they get hit with a sword, use this blood effect. So it ties it all together. Your attributes are pretty simple. Your variables, your stats of each person, your speed, your health, your stamina, your mana, your max health, your max stamina, anything like that. Integer based variable typically is an attribute, something you want to modify with an ability. And then how do you modify those attributes? You use gameplay effects. So I found this diagram online which actually answers it perfectly. So you first see, can you activate the ability? You activate the ability. So we'll say, can you jump? Can you jump? Yes. Okay, jump the ability. Spend the resources. So this will be your stamina. It takes your stamina off. So it applies the effect that says reduce stamina for jump costs, something like that. Then you begin a cooldown and say you can only activate this every 5 seconds because you'll get tired. And then it goes up. If you get any interruptions, then it just skips applying the effect. So it might be you try to jump but somebody hits you. That's pretty much it. It's really, really simple. The only thing this is missing is after it's applied the effect here, you might say play the grunting jump sound, or something like that. That's really it, and that's the gameplay cue. That's it. The GAS system is really, really basic, but it expands it and keeps it all nicely tied together. You absolutely don't need to use it. A lot of people create their own. Epic pushes this, and they use it in all their projects, and once you get to know it, it's just one of them things that it organises your game a little bit, and it makes it a lot better. So we are going to look at doing the basic minimal C++ we need to do to add this in. I will guide you through it all, and if at any point you're running into any issues, comment below or contact me on Discord and we'll get you resolved. Typically, the issues come around with Visual Studio being a pain in the backside. That's really it. And that's just where you've not got a package installed. Linux and Mac users, if you've installed Unreal, you've got everything you need to do it already. That's why I prefer those operating systems. So how do we get started? Let's first enable the gameplay ability system. So simply go to Edit, Plugins, and search for the ability system. And you need gameplay abilities. You can also add gameplay tags editor, which is something that we've not covered yet, but The gameplay tags that we've used on previous videos are a fantastic way and are really key to make the gas system work, because you can say, hey, everyone who's in range of me, give them a tag of area of effect poison damage. And then their ability system component will check that and say, hey, we've got these effects that say activate this when this tag's active. And then all of a sudden they all take poison damage, which is why the tags are so key. So add that. The next step is we need to convert your project to C++. Now this was a big pain in Unreal 4 to do, but in Unreal 5 it's so much easier. I do recommend you taking a backup of this just before we do it. I've done this loads of times at this point, just converting to C++, and I've never had an issue. Again, if you do it and you get an issue, just contact me. I'm sure we can help each other. How do you do it? So go to Tools, New C++ Class. This will convert it to a C++ project. It shouldn't change anything in your project except making it C++. After we've done this, just load it up like you normally would through the Epic Launcher. If you ever get any issues, just launch it through Rider or Visual Studio, whatever you have, and it will just load up and compile, then you can go back to using it. That's the only difference. It adds an extra step to say, hey, compile the C++. If you're not changing it, you don't need to compile it. It's like coding a blueprint. You can't use it without compiling it. That's the only difference. So there's only 2 C++ points we need to add. We need to add the attributes, so your health, your stamina, your mana, stuff like that. And we need to add a base character to apply these effects. That's it. That's the only thing we need to do. So I'm going to come to all classes at the top, and I'm going to search for attributes. If you can't see attribute set, just double check you've enabled the plugin and restarted the editor. After that, click next and give it a name. So I'm going to call mine base character attribute set. So this is all my characters are going to use this attribute. You can use other attributes, but you typically create one. And I'm just going to click create. So this is going to go through and convert your project to a C++ project now. Super simple. It doesn't change anything in the game or how you do anything. And it'll take some time to load up. Once it's done, it should load up and look like this. I'm using Rider, so mine's going to look slightly different to yours depending what you're using. Rider is free if you don't know what to use. This is what I use, JetBrains Rider. It's free, you can just download it and use it. If you're on Windows, you do need to install Visual Studio Community Edition, minimum. So this is this one here, Visual Studio 2022. If this 2023-2024, feel free to install that. It's not out of date, they've just stuck with 2022 and left it live. So install the community version, and just when you install it, make sure you tick the Unreal C++ part, otherwise it's not going to work. Once you've done that, you'll have some code like this. And it's super simple, so I'll try to relate it back to Blueprints as much as I can so you know what it is. So in Blueprints, you typically have your variables and components on the left in the little panel. So let's go and load up the player, because then we can compare, look. In Blueprints, you have your variables, your interfaces, your components here, right? This is your header file in the C++. All this code here is your C++ file. So in C++, you've got your header file. This is where all your variables go. Your C++ is where all your code goes. That's it. It's super basic like that. So you'll notice that anything red here is an error. And this is saying it doesn't know what this is. And that's because, if you read the errors down below, it doesn't know what this attribute set is. This may also error for you. It's super simple to fix. Just like you go to edit plugins to tell Unreal, your blueprint, how to use a plugin, we need to do the same for the C++ and say, hey, you know what this plugin is. So if you come to your project.build.cs, so mine's called YouTube Tutorials v3, yours might be called something else, just open that up, you'll get something that looks like this. Super simple. Using is just basically, I'm using this plugin or this code file. Public class is a new blueprint, essentially, with the name of YouTube Tutorials v3, and its parent, just like if you create a character, the parent is a character class. So you can see here, my parent is this sandbox character for me. This one is just module rules. In here is an event or a function. Ours is just called YouTube Tutorials v3, and it's got an input parameter here. So you'll see here, public dependency module names is the name of the plugins the C++ is aware of. So at the moment, it's aware of the core and core UObject and engine, which are all Unreal core logic, and input core is how you used input. So you can say when you press this key, do this. We're going to add 3 new ones to this. So just after the speech mark and before the bracket, press comma and press space. In programming, you kind of have to follow almost identically, but I'll let you know where you can change it. But you want every single capital, every single symbol the same. So if it errors, it will typically tell you what you've messed up. In speech marks, don't use single quotes, you want speech marks. We will tell it to have access to enhanced input. And if you've got the little box here popping up, that's called IntelliSense. Just press enter to add it. Visual Studio has the same thing. After the speech mark, press comma and also add gameplay abilities. And you also want gameplay tags, like so. So this is going to tell it, hey, this C++, you know how to use the enhanced input system, the gameplay ability system, and gameplay tags. And now you'll notice if we go back to the C++, it now knows what this is and it knows how to use all of this. So a lot of the C++ we're going to be adding is generally copy and paste. That's it. There's going to be very, very little we have to type out ourselves, but I'll probably type it out to explain bits to you anyway, to show you where you configure it yourself, because your game's going to be different to mine. So below, I've pasted a couple of links in. I've pasted this gameplay ability system documentation by Unreal. It's a lot better than it used to be, trust me. But it's got links to everything and how you install it. I'm also pasting in this gas documentation here. And this is basically, this one guy in the community has listed every single thing they can think about the gameplay ability system. So you can see there is absolutely loads. Panic over that and think, oh my, there's so much to learn. No. This is just a check sheet if you want to do something advanced later on. So for example, if you come down and say, what's the difference between a base value attribute and a current value? You click it, it will explain every single thing in the most detail you can understand. You could also paste chunks of this to ChatGPT and get it to summarize you if you really wanted. So I sometimes come to this if I forgot how to do something specific. I'll come down, I'll find it, go, oh, how do I cost gameplay abilities again? You can just come and click it and it tells you. Often, it will tell you the C++ how to do it, and it will show you some blueprint logic as well. But I've also pasted a third link in, which is just everything we're copying and pasting today, so you can follow along with that if you want to. But equally, if you want to type it out, that's okay too. So the first thing we're going to do is we need to give our C++ header file a macro. What is a macro? A macro is basically an automated chunk of code. So we can say, hey, we're going to create this attribute for health, apply this macro to it. And what that means is when Unreal compiles it, it's going to go, hey, replace this macro with this huge chunk of code to make it easier to work. So our attributes goes from a couple of 50 to 100 lines to that's it, because the macro takes care of everything. So the macro code we need is actually just this chunk here. You want to paste it underneath all the includes but above the U class. And what this says is define a new macro called play attribute accessors where you pass in the class name and the property name. And it's also done 3 other macros. Look, all of these will be used in some point, whether you do it or not. It might use it in the background, but they're there. These slashes just mean also follow on with the next line. So that is essentially the same thing. The slashes just let you put it on the next line. So make sure all the capitals are there, the hash, the spacing, make sure that's all there. If you paste it in and it's all colourful like that, you've done it correct. So these give us a bunch of different logic we can add super easily. So let's go and add our first attribute then. So inside this class here, which is the equivalent of creating a new blueprint class, we're just doing a C++ class, we need to tell it that this attribute is publicly accessible. Things can go and grab this variable. So in here, we've got this quest papers variable. We need to tell it whether or not the variable we're adding is private or public. So if I tick private, nobody else can access that. No other script. Only this script can access it. If I uncheck it, it's treated as public in here. We need to do the same in C++. So just press enter underneath generator body, and in all lowercase type public, everything under here now is going to be treated as publicly accessible, so things can use our attribute. So the first attribute, let's add something 99% of you are probably going to want to add, the health. Super simple. Let's first tell the C++ we're about to define a property or a variable in Unreal. So type U property in all capitals, add your 9 and 0 brackets, and inside of it type blueprint read only. And what this basically means is this variable can be read by people but it can't be written to. Because we don't change the attributes directly, we make effects do it for us. Because then it limits how many things are changing your game. If you had 50 NPCs and 50 traps all hitting your player, you're going to be changing it from everywhere. It's hard to track it. Whereas if we limit the scope of it and say only these effects can change it, you pretty much know where all the changes are coming from. Then under here, let's define our attribute. Capital F, capital G, F gameplay attribute data. And then press space after the data type and give it a name. So I will call mine health. And you need to put the semicolon on the end of this line. You don't need to do it on the line above because again, that is technically one line like so, but the standard is you put it underneath so it's easy to read. Now under the health attribute, we can now use our macro. So we're going to go and get the play attribute accessors macro and we'll paste it right there and open our 90 brackets and it'll say, what class are you using? Well, I'm using my base attribute set here. And I know it's got a U at the front of it. That just means it's an Unreal class. Just make sure you put that in. You don't need to rename your files to say U, otherwise it'll say UU, and you don't want it to do. So just copy that and paste it inside the brackets. Comma space. The space just makes it look nicer. And then we need to put the name of the variable we're using, which is health. And at the end, put a semicolon. Now you'll see it's erroring, and if you hover over it, it will roughly tell you the error. But typically, if you see this error here, type something is incomplete. That means you've either not imported it or you've not set it up correctly. We know we've set it up correctly, but we just need to import one thing, which is to tell this, hey, this is how the gameplay ability system works. Because even though we've told the C++ what it is, we need to tell this specific script as well. It's how you keep your game very lightweight. So if you've ever done interfaces and you've got casting everywhere, we don't want the C++ to have links to every single code file. It would be huge. So just above the generated.h, don't put it below, otherwise you'll have an error. Underneath the attribute set, just hash or pound include, which is saying include this code file, and in speech marks, type ability system component.h. And you'll notice the error will instantly disappear. The ability system component is a key thing we're going to be adding to our characters, which basically is the gameplay ability system. It controls their attributes, their abilities, their effects, their cues, everything. It is the brain of gas, if you wish. Now, those 3 lines are pretty much how we define an attribute. It's super simple to do. But we're going to take it one step further just to give you the best start to gas you can. And we're going to define event dispatchers for these properties as well. You can equally also call them delegates. That's what most programming languages call it, a delegate. I don't know why Unreal decided to change it for the blueprints, but they did. So just like in here, where we come and create an event dispatcher, we're going to do the same in C++. Underneath your macro here, just press enter a couple of times to make it nice, and type all in capitals, so hit that caps lock, declare underscore dynamic underscore, and then you've got a bunch of different options. We specifically want the multicast underscore, and then you've got a bunch of different ones again. So we need the specific 2 parameters delegate, and we're going to say that this attribute has been updated to this value. So we want 2 parameters. So I'm just going to double click that. If you ever decide to add more parameters to it, so maybe you want to say, I'm updating this attribute with this value, the old one was this, and this is the person who's changed it, just add the 2, 3, 4 parameters delegate macro if you wish, because this is a macro. So the first thing we're going to pass to it, so parameter 1, so you can see here, it's highlighted specifically what we need to do. So the first one is going to be the name of our delegate or our event dispatcher. So we're going to say F attribute event is typically what Unreal standard is to call it. And I'll press comma and press space. And then the next attribute will be the data type that I'm passing to it. So I'm going to say it's a type of float, comma and again, and I will say this is what we're changing it by. So I will call it effect magnitude, which is what, again, Unreal calls it. Press comma, I'll send it another float for the second parameter, and that name will be the new value. And semicolon at the end of that. So this delegate we're going to use to basically tell everything in our game when this attribute updates. So for example, if you have a health bar on screen and we want to check it and update the bar when this health changes, you're probably going to want the event dispatcher to handle this. You could have a tick, or you could rely on every time the player takes damage or health, it tells the UI to update, but then that's coupling it tightly together. If the user goes and unticks the UI, you've then got a job of saying only update the UI if that's also not ticked. Whereas if we do it another way, and our player simply says create the UI if they're supposed to, then our UI listens and says, hey, tell me when health updates, I'll do it myself. It's a lot easier and it's a lot more accessible. So now that we've done that, just under the health here, let's give it the event dispatcher. So now we've defined how we're going to use it. And because it's a macro, it does loads of code for us, so it's nice and quick. Simply type U property again, because an event dispatcher is counted as a property. And we will say it's blueprint assignable, which means we can bind blueprint code to it. And we can edit it anywhere, which means we can also bind C++ to it or change it if we need to in C++. Underneath that, you can see it's already tried to do it for me in my editor, so I am going to press tab, but you basically want F play attribute event, which is the name you specified up here, and then the name of it, so I'm going to call mine on updated, but you can change this to anything you want. And that's it. That is how you define a macro, an attribute, and an event dispatcher. So I'm just going to copy this logic here, and I'm going to paste it directly under itself. I'll make some space. I'll probably press / twice so I can put some comments in, and I'll call this one max health. And then I'm just going to create a new property again called max health. So I'll change the name, I'll change the play attribute accessors, and then I'll also change the event dispatcher there. So now if you want to add more attributes, you can go ahead and do it. Now, I'm going to add a couple in for myself, so I'll probably put a comment up here as well for help. I'm going to copy all of this code, paste it below, and I'm going to call this one mana, paste it in, and I'm just going to replace all of the places I need to, and I'm also going to do max mana as well, because my game's going to have spell casting and stuff like that. Whilst I'm here, I'm also going to do it one more time, just so I can add stamina. Again, if you've got anything you can think you might want to store in here, you can do it. And if you don't want to add anything for now and just crack on, you can absolutely do that and come back to this later. There. So I've got 3 main groups of attributes set up, but 6 in total. Max health, mana, max stamina, max stamina. The reason we're adding the maxes as well is as it stands, gas doesn't give you anything out of the box to limit things, so you have to build that in yourself. But you could argue that just makes it more flexible for the developer. So now that we've done that, one last thing we need to do for these attribute sets is to actually apply the maxes to it. Because if you add an effect to increase your health, that will just go on for infinitely. We need to tie these two together to make sure that they never go over their limit. So in this case, the health limit is the max health. The max health doesn't have a limit. If the player manages to get themselves 1,000,000 health, great. They've done a good job. Mana should tie to max mana, stamina should tie to max stamina. You absolutely don't need to do this if your game has an infinite way of doing this, but for example, if you pick up a mana potion, you can either keep it going up and up and up and up and they just spend it, or you limit it like most games do. So, how do we do that? What I'm just going to do is add this to the top here so we can easily get back to it again. Override one of the events inside. So if you've never done overrides before, you can see in this function here, we've got all of these overrides here we can do. And this basically says, hey, this parent class, so actor, has this function and it does this code. We can override it and say, hey, we want to change what that does. And that's what we're going to do on here. And that's completely normal to do. So we're going to say virtual, which means we're about to override it, void, which means it's not returning anything. Otherwise, you'll return a bool or something, but we only want it to not return anything. And we want to override the function post gameplay effect execute. And this is after a gameplay effect has been executed, run this check. So a gameplay effect is about to execute. So this says this gameplay effect is executed. Here's what it's changed. So you can see it's automatically added this code for me, but let's just review it. So it's post gameplay effect to execute with capital start letters, open 90 bracket, const means you can't change it, so define a new input parameter we can't change. It's a type of struct or structure, which we've done before in blueprints. The type of it is F gameplay effect mod callback data. It's a built-in structure, you don't need to worry about it. The ampersand, I'm not going to get into it and confuse it. And then the name is data. Close the bracket and just say I'm overriding this. Now, because we need to change what this does, we actually now need to move over to the CPP file. So far, it's been really easy, and it's still going to be easy. None of this is going to be challenging. Like I said, a lot of this is copying and pasting. So I'm just going to come down here, and you've got two ways. You can, in Rider or Visual Studio, you can Alt-Enter or right-click it, and it'll say, do you want to generate this definition in base character attribute set.cpp? You can copy to clipboard or you can just click it and it'll add this code into our C++. If you don't have that option, then simply come to the C++ and basically write this out with your name in. And again, we've just covered what this does. And the super, this basically says, hey, go to whatever we're overriding and just make sure you run that code first. That is the same here, right-clicking and doing add call to parent function. But we don't want to do that, so we're going to get rid of it like so. So in here, what we want to do is basically tie our maxes and our currents of all the attributes together and say if you go over it, clamp it down. So don't let it go over it. So the first thing we're going to do is at the very top of the includes, we're just going to tell it so it knows what's inside this. At the moment it knows it's here, but it doesn't know what's actually inside of it. So just below the include, put hash include, and in speech marks type gameplay effect extension, no S. And now it knows what's inside this here. You can either right click and go to definition or press Ctrl or Command B and it will show you here's what's inside of it. Look, that's the core C++. So in here, let's add a branch or an if statement and open our 90 brackets and type data, which is our variable, dot to go inside of it, evaluated data, so do dot again, so get the attribute that's changed, get us the data inside of it, and we'll say is the attribute, and do double equals, which you have in the blueprints, and say is it our get health attribute. And you'll wonder, where did this get health attribute come from? That is our macros in session. So this macro up here is using this gameplay attribute value getter, so get health attribute. It's preset itself up when we actually assigned the attribute look, which is really nice. Every single one of these will have one. Then after the bracket, so make sure you put a closing bracket on it, press enter and put curly brace and inside of it like so. You'll see some programmers do it on the same line like that. They are wrong. No, they're not. I'm not going to start that fight. There are acceptable ways, both ways you want to do it. Some languages prefer it like that. Some languages prefer it like that. They're both correct ways of coding. I personally just prefer it on the new line because I think it looks a bit neater. But if I'm coding in JavaScript, the standard is on the same line. So yeah. So inside here, what do we want to do? Well, we want to say, hey, this effect has just executed and it's changing this health attribute. Let's make sure that we'll let it continue to set it, but only if we clamp it down and say you're not allowed above our max health. This doesn't mean that you have to limit it and say, oh, hey, I've got a potion in my game that can temporarily boost a character's health above the max health. Add something into cater for it. That's completely okay too. So inside here, we're going to let it set the health. So we will come back and use our macro for the setter. So we will just do set health, open brackets, put a semicolon at the end and go back inside. Now we want to say, let it set it to whatever it's trying to change, but clamp itself down so it's limited to the max health. So simply type fmath to get the fmath library, which is built into the core, so we don't need to include it. Colon to go inside of it and just do clamp. It'll automatically add the brackets, if not just add that in. So we need to give it 3 values. The current value, the minimum value, and the maximum value. So the current is our get health, open close brackets, comma. The minimum is 0, comma, space. The maximum is get. That's it. That's how you clamp it down. Now, we do have event dispatchers, so this is a perfect time for us to say, use this event dispatcher or call it, which is what you do in blueprints. So just beneath set health, we can now tell our event dispatcher to work. So on health updated dot broadcast, which is call. Again, I don't know why they've called it different things, but we're broadcasting to everyone who's listening to this saying, hey, this has changed. And in brackets, it wants two values. So it wants what's changed and the value of it. So we will say it is the data dot evaluated data dot magnitude, comma, and then we will just say here's the new value, semicolon at the end. And that's it. That is officially our health attribute added in, clamped down, and updated. So I'm just going to put a wrapper up here saying health, and then I'm going to duplicate all of this below, and I'm going to do max health, and I'm going to do the same thing. So get max health. We don't need to clamp it by anything because the max health doesn't have a max unless you want to max health. So I can get rid of that, and I'll just say on max health updated, broadcast the new max health likes. Now you might be wondering, shouldn't we add an else statement to this to say do this, otherwise do this? And no, because there is some chances where you can actually call both at the same time. So just leave it as is. A quick way if you want to quickly replace it, just copy it all, paste it below itself, highlight it all again, Control or Command R to execute the replace. You want to replace the word health with mana. So in Rider, just by selecting it, it will only replace inside there. So you'll see if I click replace all, it will only replace that. In Visual Studio, you do have a separate button. It's something like only selected or something like that. Just tap that and do it. Or copy it to a notepad file, do the replacement, paste it back in. So I've just quickly set my mana one up, and I'm going to do the same thing again. Replace. It might also be Control H for some people. I'm going to replace the word mana with stam, and I'll do replace all. And that is our attribute set done. That's really it. It seems like a lot of code, but it was all copied and pasted. And there's the same in here, again, copied and pasted. So at this point, you've got two options. You can either try to reopen your Unreal project, but it may want you to actually compile it to get the changes, or come and close your Unreal project down and save anything you need to save. I don't need to save that. And then in your IDE, Visual Studio, Rider, whatever you're using, just come and click the play button. In Visual Studio, it's in the middle. It says something like local Windows debugger. And then give it time. It's going to take a little bit of time to compile. Depending on your hardware, it'll be faster or slower. If it's taking hours, something's seriously wrong. If it's taking longer than 3 minutes, you've got something wrong. But this is essentially going to compile the C++ and load your project up. There are a lot of dedicated devs out there who always say, just use Visual Studio or, Rider. Always compile your code that way. Mainly because it saves a lot of headache if something changes. So for example, if I'm working with a developer and I have to make a C++ change, if they just load Unreal up like normal, I have to tell them, hey, I've made this change. Make sure you compile Visual Studio or whatever your code so you can get that change. If they don't, sometimes it will just error because they've not compiled it. Sometimes it just won't see the latest update. So you can see mine's correctly gone through and updated itself. If you get any errors, it won't load Unreal up, but you'll have your error log down below telling you what the errors are. If you just read it, as silly as it sounds, it will typically tell you what the error is. And it'll say, in this file, on this line number, here are the errors. And it'll say something like, you've missed a semicolon, you've not closed your bracket, you've not put the correct capitals on. So just look down the files, compare my two files and yours, and just make sure they are the same. After this video as well, what I will also do is add a fourth link of my finished code, so you can compare. And you'll see mine is successfully loaded up. But we need to go and create one more class, and that is for your C++ character. If you're using a plugin or something, you very well may already have a C++ character, so I'll show you what code to add in a moment. But if you don't, for example, I'm using Gasp, so I've just got this sandbox character, so I'll edit that, and you'll see that base class is just a character anyway, which is C++. Fun fact, if you've loaded it up with Visual Studio or Rider, you can actually click this now, and it'll take you to the Unreal code. And remember, we've just looked at this, so you can see, hey, it's got a bunch of delegates up here for 1, 3 parameters called different things. It's also got a structure in here with a bunch of different properties. Look, is active, that one. Position, you've got loads of different stuff in here. You've also got some engine API stuff. There's loads of stuff in here that you're going to be a bit more familiar with now. But we need to tell the C++ to have a custom character and add our ability system component. This is the last bit of C++ we need to do. So it's super simple to do. Simply go to your main window, Tools, New C++ class, Character, Next, and call it something you want. So I'm going to call mine Base Character. And this base character I will use for everything. NPCs, animals, the player. Everyone will inherit from this, and everyone will have access to the ability system component. There may be some very rare instances where you don't want somebody to have it. Maybe it's an immortal deity that doesn't have any health or anything. You might not want it, but that's really a very rare occasion. Just click Create Class, and it'll go off and do it. It should be a lot quicker this time because you've already done the big conversion. And if you hear that diddly-ding thing, that weird sound Unreal does, it means the C++ is loaded up. So this looks a bit more complicated. There's more C++ code here. But let's just read it and just see what it is. Include base character.h so it knows what our variables are. Base character, we've already looked at this on the build.cs, so that's just some basic things. And all it's doing is saying, can the actor tick? Yes, that's just an option. We've got begin play and set up player input component, which you can ignore that one, that's just one built into it. But that's really it. Here's your event tick, here's your event begin play. It's really, really simple. So what changes do we need to do? So let's go back to our base character.h here, and you see we've got some stuff in here. We're saying our parent class is a character, we're called base character, we're overriding the begin play, and the tick, and the setup player input component. It's all already there, look. Nice. So, well, let's add an interface to here that to use the ability system component. So in Blueprints, you'd go to Class Settings, Implemented Interfaces. In C++, it's actually really easy. Just after this parent class of character, public, because we want it to be publicly accessible, ability system interface. Now you'll notice it didn't pop up with it. That is purely because I've not told it to include it. So above the generated, always do it above generated. You very rarely have to type that out yourself. Inside here, hash include ability system interface.h. For good measure, also add another include under it of abilities, and you'll see we've got a folder / gameplay ability.h, so it knows how to use it. We're going to use that in a moment, and you'll see it's now gone blue. If you press Alt Enter on this, now that we've got this interface, we can start using the functions this gives us. So if we Control Command B, you see it's got 1. That's all we're using it for. Get the ability system component. Technically, you don't even need it. You could literally just say get component by class. This just makes it a bit easier. So in here, inside the public, you can either do it on this one or this one. For some reason, Unreal's decided to flip it around. You can even clean it up and just do that if you really want to. It's the same thing. It's just the way Unreal does it. I'm just going to put it under this one. Just type U ability system component, which is returning the ability system component. You want a star, which again, I'm not going to go into. It's to do with memory management and whether we're getting the value of it or we're making a copy, stuff like that. We're just going to implement the function we saw on there, get ability system component. You can see it's already done it. It's added the word const override onto it for me. That's just Rider being really specific and trying to make our C++ the best it can. Const means we can return this, but we can't change what it's doing. And override just means we're overriding this. If you hover over it, it's saying, hey, you've not implemented it. Alt-Enter, generate definition, or go and type it out yourself in the C++. It should look like that. You'll see this is erroring because it's not returning anything. So what do we want it to do? Well, we want this to return the ability system component that we're using, but we've not given it one. Super easy. Back on the header file. Inside protected. So protected means only I and any children of me can access this, but nobody else can access it. So you can't have a random NPC getting this ability system component without going through that function. So inside here, let's add the ability system component. So it's a type of U property. So we'll type that in. U property, all in capitals. In the brackets, we're going to say we can edit this anywhere in C++. It's blueprint read only, which means our blueprint scripts can only read it. They can't be changing it. And the typical standard is for this meta tag. If you just press enter, it goes a bit funky. Look, it adds equals and brackets. And inside here, just type allow private access. equals true. And this is just something you set in C++ to say blueprints are allowed access to this. That's really all it says. So inside here, we can type class U ability system component. You can see it's already done it for me. But the class is saying we're adding a type of component or a class file. The ability system component. The star is more memory management, so you don't need to worry about it. And just give it a name. So I'm going to call mine ability system component. You can call yours anything you want. And now with this, we can jump back to our C++. And we can simply say, hey, if you want our ability system, return our ability system component. So now that we've got an ability system component here, we need a way to bind the attributes onto them. To say, hey, your ability system component, here are your attributes. So just under it, type U property. And realistically, it's just the same code as up here. So you can copy and paste this one or let your intelligence do it. Then under it, const. So once we've set it, we can't change it again. Class. And we will do our attribute set. So U, because it's a Unreal class, base character attribute set. And we will just call it default attributes and semicolon. You'll see it's erroring here because I forgot one minor thing. Just put a star just after the data attribute like so for the memory management. And that's that part. Now, there is technically some other benefits we can do with this that we're going to get onto in a moment about applying default abilities. So when your game first loads, instead of having to loop through everything, we can just say, hey, apply these abilities by default. But we'll get to that in a moment. Let's actually make our attributes work. Back into our C++ file. The first thing we need to do is actually initialize this component. We've said, hey, you should have an ability system component, but we've not told it to actually create it yet. Inside this base character here, this is called an initialization method or an init method. Think of it as your construction script. So the first thing we're going to do is say, set the ability system component equal to create default subobject, which basically says create an Unreal object inside of it. In angle brackets, or I believe some people call it crocodile teeth or something, open close angle brackets, more than less than. We're going to create the type of U ability system component, and in the brackets we can set the name of it. So because Unreal lacks its localization text, all in capitals type text, and mine's already done it, look. Basically, text, open bracket, speech marks, call it whatever you want, ability system component, and close it off. Now that we've done that, we just need to apply the attributes to it. So on event begin play, after this has been initialized and it's all set up, so we don't want to define the attributes on here because it's setting it up, it'll go off and do some other stuff. Event begin play, we know it should all be good. So underneath the super begin play, which just says, hey, do whatever your base class character's event begin play is. We'll just double check nobody's removed the ability system component for whatever reason. So a good safety check. So just branch if ability system component. And then inside here, the first thing we can do is say, hey, init yourself. Basically, get yourself ready to apply effect. So we're going to simply say ability system component, arrow, which is a minus and a more than symbol, init ability actor info, and we'll just say this, comma this. I'm not going to go too much into what that's basically doing. We're basically saying inside this, call this function, passing this character. Now underneath this, we can basically tie the ability system component's attributes to our own default attributes and basically say, hey, join these together. So we'll say default attributes equals the ability system component arrow function get set function, which basically does the tying together, angle brackets, our U base attribute set, angle bracket, open close bracket, semicolon. So tie them together. And that, ladies and gentlemen, is essentially it. We have now added a single player gameplay ability system to our game. That's it. You could stop the project running and reopen it, then basically at that point follow most gas tutorials if you really want to. But I'm going to add some safety or helpful functions in for you, which basically will just help you do more things going forwards. So one of them I mentioned was the ability to add default abilities to your character. So back on the base character H, and you don't have to do this if you don't want to, but it's going to be helpful for you later. Copy this bunch of code up here again for the default attributes, paste it below, and under here, type T array, which is creating a array in Unreal, open the angle bracket, and we want a T subclass of, which basically says use this, make an array of this class. And the class we are using is the U, and you can see it's done it for me already, but it's U gameplay ability. And close the angle brackets twice for the class, subclass, and the array. Space, and we will say this is the default abilities. So we've created an array of gameplay abilities. Then in our C++, let's apply these abilities. So inside the event begin play, just under default attributes, press enter. And now we can loop over the array that we've just set up. So we will just simply do for, and there isn't a for each in C++, like there is in Blueprints where there are two distinct nodes. In C++, you just do a for, and then you tell it what to loop over. So we're going to say loop over our subclass, so T subclass, angle brackets, U gameplay ability. And you can see it's done it for me already. So U gameplay ability, close angle bracket, we'll just give it a mini name, so ability. That's just what we can grab when we're looping over it. Colon, which says what are we looping over? The default, and it's done attributes here, that's not correct. We want abilities, default abilities. So even the auto generation got it wrong, look. After that, add a closing bracket, enter, curly brace. You don't need to put a semicolon here, the curly brace handles it for us. Inside of here, we can now grant these abilities. So simply, ability system component, arrow function, give ability, and you'll see it will automatically add that, but we need to give it a tiny bit more. So we'll just instead say F gameplay ability spec, and this is basically going to say apply this ability, but with this specific specifier if you wish. So in this case, in brackets, we're going to say apply the ability. What level do we want to apply to it? So we're just going to do default level 1, but abilities can have levels. So you can say at level 1, you can jump. At level 2, you can double jump. At level 3, you can jump as high as a house. Or you can make it scale and say between 1 and level 99 is how high you can jump, or how much damage you do, or what abilities you get from it. Stuff like that. Comma after that. And then you can specify here if you want to attach a specific input to it. So if you press space, it does jump if you want to. We're just going to say index none. Don't apply any inputs, we'll handle that ourselves. And then just put the word this. This is just what's adding it, which is this script here. So it's in case you need to find what's adding this. And that's it. We can now give this a comment, give default abilities. Super simple, right? We can also give default effect. So if your game loads up, you pick a class of elf. Elf instantly gets a mana boost because you've picked a special elf and a special dialogue path. Apply the default effect of mana boost. We can do that as well. So let's also add that in to make it easier for us. So back to the base character. Again, just duplicate all of this below itself. Everything's the same, but instead of U gameplay ability, gameplay effect, and then default effects. Back to the C++, duplicate this entire for each below itself, so give default effects. We're looping over the U gameplay effects. Its name is effect, and it's our default effects. So the effects are a little bit more challenging than a single line. First thing we're going to do, and we'll do it above as well, is in Unreal, you know when you click add on an array and it says none, and you set it, if you forget to set it or something removes it, it can cause it to error. So all we're going to do here is just say if effect, and we're going to put an exclamation mark at the beginning of it to say if the effect is not valid, continue. So just basically, if we get to an empty effect, ignore it. And we'll do the same thing for the ability here. So if ability, and we'll do the exclamation mark. Make sure you definitely put the exclamation mark there, because that means if ability exists, and we're putting that there to say if it doesn't exist, basically reverse it. So that'll stop a crash later on. But inside here, to apply an effect, we can't just say give this effect. Just like we made a spec here, we've got to do the same for the effect. And creating the spec is a little bit longer than this one, but we can do it now. Firstly, we're going to create the effect spec, or the details of what we're about to apply. So that's simply F gameplay effect spec. See, because it's already added it for me. And we'll just call it gameplay effect spec handle. And you can see it's already done a bunch for me, so we'll follow it along. It is a type of spec, or call it whatever name you want. So spec handle, current effect, something like that. And then we don't actually want that. What we want to do instead is type ability system component to get that. Arrow function, make outgoing spec. So we're about to apply a spec, create one. Then the first option we add in is the effect we're applying. So that's that one. Then we want to apply what level are we going to apply this to, because effects can also have levels. So you can say at level 1, apply 10 health. Level 20, apply 500 health, stuff like that. So we'll just put number 1 in for now. And then it's asking for this context handle. So in what context is this being applied to? So who's it coming from? Who's applying it? Because when you apply an effect, you can say, who gave me that effect? Was it me? Was it somebody else? So if a boss damages you with fire, your ability system component will store who applied that fire. So this is going to take a little bit more. So just above the for loop inside give default effects, press enter, and we will create a new F gameplay effect context handle, just like we did down here, but we're doing a context handle. Then we will call it effect context, something like that, equals ability system component, and then just like we did below, make effect semicolon. We've got our context handle. Who's actually applying the effect to us? So we'll do effect context dot add source object, open brackets, and we'll just say this. So this character is applying the effects to us, which is ourselves. So that's, and now we can just paste that effect context inside there. So that's now created the spec. So we're saying, hey, we've got this effect. It's level 1. It's going to be applied by the player. What do we do with it? So underneath it, we'll just first check it's actually valid still. It's already done it for me again. This is why I love Rider. So we're saying if spec handle is valid, because it could be that this effect has actually got a blocker on it to say no more effects. It's got a shield or whatever. So this will check, can you actually apply it? So inside here, we'll now apply this effect. So we will simply say ability system component, arrow function, apply gameplay effect, spec to target. So you'll see there was 2 there, to target and to self. Self is apply it to me, but since we've already set it up here to store who we applied it to, we'll use target. In the brackets, put a star, because for the memory management again, and we will do .data.get. So get us the data of the spec that we're applying, and then we're applying it to the ability system component and semicolon. So I have noticed I made this one lowercase. I shouldn't have done that. Let's just make it uppercase. That's just standard. It's not really an error thing. And that's it. We now have the way of giving default abilities and default effects, meaning we've got a lot of really good stuff in. I'm going to go and add one more thing, which is very, very useful, and that is to check when the player has died. Because an is dead check is really, really useful. You can, of course, just get the attribute and say, does the health equal 0? That is one option. But we can also add a quick function to make that a lot quicker. And instead of saying, hey, get me this character, get me their attribute set, we can also say, hey, get me this character, get me their ability system component, get me their attribute set, get me their health, check if it's 0. That's a lot of work. We can automate a lot of that and make it a bit easier. So back on our base character.h, and I promise this is the last C++ we're going to do, we'll add a function that returns whether they're dead or not. So inside public, because we want other people to check this, because for your AI, you might say, hey, don't attack them, they're dead. So we can add this check to see if they're dead. So we will simply say U function, because this is a type of function we're creating. And we will say it is blueprint callable, so the blueprint can call this code. Then under here, we want it to return yes or no, so a bool to whether it's dead. And we'll say is dead, open close brackets, and we'll just put const because we're not going to be editing it. You'll see it's yellow, so we'll implement it. There we go. So just type the code or let it do it. And now we can check if the character is actually dead. So it's super simple. First thing, let's make sure they've actually got an ability system component. So we'll say if they haven't got an ability system component because somebody's removed it for whatever reason, we'll just return false because we don't know if they're dead or not. But if they do have one, then we will return the ability system component, arrow function, get set to get the attribute set. So our attribute set is our U base character attribute set. And then after this, arrow function, get health, is less than or equal to 0, and you can let it complete like that. So that simple function will now let us get all of this to check if they're dead really, really quickly. Not just a nice shortcut. And as I said, that is the last C++ we're going to do for now. Now, I am aware this video is getting quite long, so we're going to do a basic implementation, and I'll show you just very quickly how to do some basic calls for what we've done, and then we'll go from there. Again, when it's compiling, if you get any errors, just try to read the error and see what the error is. If it's not obvious, comment below or reach me on Discord for a more quicker answer. But we do indeed have a single player gas setup. A lot of this was copy and pasted, and then we added extra functions to make our life easier. You absolutely don't need these death check, or the default abilities, or the default effects if you don't want them. So how do we actually use it? Open up your player. We'll start with that. And then if you've got any parents of your players, open that as well. So you can see here, my parent class is just a character. So let's change that. Go to class settings and let's apply our new base character. And you'll see it will change it, but because we're just changing from a character and inserting extra data, it's fine. You can see it's not errored. The game at this point will work the same, but you now have an ability system component. How cool is that? And what we can do with that is we can come to class defaults, and if we just search for default, we've got default effects, default attributes, and default abilities. So let's set this character's attributes up so we can say what their health is, what their mana is, what their stamina. I'm just going to come to my content drawer. I'll create a new folder in here called gas, not to be confused with gasp. Inside here, I'll just create another folder called attributes. And then I will right click miscellaneous data table, because that's how the attributes are stored. And we will just search for attribute metadata and click OK. I will call this attributes, because I know you normally call data tables DT, but this is an attribute set. And I will call it, or in my case at least, because my game's specific, player night. And I'll open it up. So this is where it gets a little bit funky, and I really hope they change it in the future. When you click add, you need to set the row name to be the name of your attribute set dot the name of the attribute. And what I mean by that is if you come back to your attribute set, we've got health, right? And ours is called base character attribute set, not the U, ignore the U. So inside this data table, you have to call the row name. Let me expand this out so you can see. The name of your attribute set, so base character attribute set dot health. It's weird, I know. I'm hoping they fix it in the future. The theory is you can apply multiple attribute sets all at once if you really want to. I've just never seen anybody do it that way. And now we've got a bunch of values here. The base value is the value of it. So their health, I'm going to say by default, is 100. Now you'll see we do have a min and max value. As far as I'm aware, they are not used. It seems to be either a legacy thing or something that's coming up. So I'm just going to set them to all the same thing. So if it ever does come and the update applies, we've got the option there. But as far as I know, at the moment, it doesn't matter. It doesn't do anything. And now I can do this for all of my attributes. So I'll click add. I'll copy the name of this, paste it here, and I'll do max health. I'll say the max health is 100. Minimum is 0. Maximum is 100. And I'm going to do it for each individual one. To make it a bit easier, you can also duplicate the row. And I'm going to call mine mana, which for the knight, I'm going to severely tank because he's almost not magical at all. I'll duplicate it again for the max mana, which again, almost not magical. I can duplicate it one more time for the stamina. This knight's probably a bit more full on stamina. He's a knight after all. I'll duplicate it one more time for max stamina. And now with that, we can jump back to our base character, select our ability system component. You will have default starting data, open it up, and then inside here, apply your attributes. So base character attribute set, the default starting table is our attributes player 9, at least for this one. On children, you can of course come to it and also apply it there. So if I had someone else, I could apply it that way. And that's it. You can start your game and everything will function completely as normal. Nothing will change. See, the game completely works like normal, nothing's changed. But how do we actually make it work? So this will be the last thing we'll do in this tutorial because, like I say, it's very long at this point, but we will continue this on in other videos. So let's make a basic ability. In my character, because I'm using the gasp system, I have this event on jump, it runs the jump thing here. So right at the end, it calls jump. But what if we can make that an ability and we say you can only jump when you're allowed to? You might think, well, that's a bit silly, isn't it? Why wouldn't they always be able to jump? Well, what if they're tied up? They can't jump then. What if they're in a menu? You can also do that. If they're climbing through an area or they've got something above their head, you can restrict it in any way you want. Say their health is below 50, you can remove the ability to jump at that point. And that's where it becomes really, really flexible. So let's do it. Let's give them the ability to jump. So I'm going to come back to my content folder. In my gas folder, I'll create a new folder called abilities. Right click, blueprint class, and search for gameplay ability. And we just want the standard one, not the character jump one. There is a built-in one for jumping. We're not going to use that because we need a custom implementation. Click select and call it GA for gameplay ability jump and open it up. It looks pretty normal, like your standard blueprint, which it is. The two key functions are activate ability, which is when we say you can run it, and on end ability, which is when it's finished running. In class defaults, you've got all your different tags that you could absolutely use. So you could add tags with jumping, then you can't shoot, or you could block. If they're tied up, you can cancel it, all sorts of stuff like that. So what we want to simply do here is essentially replicate this jump code here. This jump comes from the character itself because it's a type of character underneath base character. So back on our gameplay ability jump. So to get the owner or the person who's running this ability, because that's the way you have to think about it, it's not just the player running this. This ability can be granted to anyone. We can simply go get actor info, which will get the person who's running or owning this ability. We will break on this struct, and it's going to give us the owner actor look. From here, because it's a weak object, so it might not always exist, we're just going to cast it to a character just to make sure it does exist. And then from here, we can just simply tell it to jump, just like that look. On end ability, we can also do roughly the same thing, so if just paste it down here, because on end ability will also fire if we remove it. We will just call stop. And now we can hit combine and save. That's really it. So if you come back to your character now, if we remove this jump and instead add the ability system component in, drag off and say try activate ability by class, plug it into true and say activate the jump ability. So now what you'll see, if we compile and save, if I just start the game now and press the jump key, it will no longer work. See? I'm pressing jump and it's not working. Can you figure out why it's not working? It's because we've not given it the ability to jump. So back on our elven character specifically, because I don't want all characters to be able to jump, on our class defaults, I'm going to search for our default abilities. So you've got it there, and let's give him the default ability of jumping. Compile and save. And if we play it this time, you will see we now should have the ability to jump. And I've just had to jump to a different level because for some reason that level kept crashing. Nothing to do with the C++ and Rails, just being really flaky for me. But you can see we can now jump. Look at that. All from the ability. And it might seem a bit basic at first. I was like, well, why? Couldn't that just be a branch or an if statement? Absolutely, it can. But the benefit of the way we've done it here is we can grant that anywhere. So for example, if we come and remove the ability to jump, like so, on our player, if we just do debug key L, whatever that's going to do, we can get the ability system component, we can do give ability, and we can do jump. So just with that, look, if we play it this time, we've lost the ability to jump. If I press the L key, just like that, we can now jump. So that means if we're tied up or anything, or in the game's story you've not unlocked the ability, you're a baby, you can't jump yet, you've now unlocked the ability to jump just by pressing that. Other very common uses are dialogue grants it to you, a deity gives it you, a shop, a spell book. All of that can be applied super easily, just like that. And the same goes for effects, but we're not going to cover that in cues and everything. But there we go, ladies and gentlemen. There is the way to add gameplay ability system into your game for a single player game. I keep saying single player because it does not have replication in. If you want to see that, go and check out the documents I've linked below. A lot of them build it for replicated games. I'm not building a multiplayer game, so I don't need it. But there you go. I hope that wasn't too bad. I know C++ puts a lot of people off, and the amount of developers I've heard say, if it's C++, I'm not touching it. That's okay, but trust me, it's super worth it having this in, because you've now unlocked a whole new world. If you like this, please hit the thumbs up below. It helps the algorithm push videos like this around to everybody. I've also linked an empty project with just the pre-game playability system set up with a bunch of defaults on my Patreon if you want that. That gives you just, if you're starting fresh and you don't want to do the C++, it just presets it all up for you. I've also linked all the documentation below if you want to see any of that. And if you want the next part of this episode, that is also linked on the Patreon as well. So thank you for watching. My name is Decryption, and I'll see you next time.